Okay, here's what we're talking about today. We are talking about graphs of polynomials and some stuff about their behavior. Any one thing we talk about today is easy, okay? But it's kind of a lot of small, easy things. And so when you go to keep all of that stuff straight eventually, that will be the hard thing, okay? So it's a bunch of easy stuff that you still have to keep straight, but so that's like pros and cons of today's lesson. We have already talked about graphs of some kinds of things, mainly parent graphs, like the identity function, square, square root, cubic, cube root, right? We've talked about those. What we're going to start talking about this unit is graphs of higher degree functions, and we're going to call those are polynomial functions. Okay, a polynomial just means many terms. So that's what right? Poly means many, and then the rest means terms. So here's some, on this first piece of your notes is just some characteristics of polynomial graphs. And if a graph fails any of those, we would just say it's not a polynomial graph. So here's the first thing. It must be continuous, which means there are no breaks or jumps in the graph. So remember when we did piecewise functions? Not like that, okay, because those jump, they break. The domain, negative infinity to positive, okay, that's part of being continuous and smooth. The x values go on in both directions forever. Not for the range. Good question, just the domain. The graphs are smooth, meaning no sharp turns. Which parent function do we have that has a sharp turn? Right? Absolute value has a sharp turn. That is not something we would consider a polynomial graph, but something like this would be, right? Because it has a smooth turn. And then we're going to be using some information to find not the actual degree of these. What we're going to be doing is estimating. We're going to be finding the least possible degree. And I'll come back to this. This is just a little rule. I'll come back to it in a second. It's the number of turning points plus 1. Like, for example, I just drew this as x squared. A turning point is where the graph turns from one direction and goes completely in the opposite direction. It doesn't just kind of shimmy. It completely turns. So like this is a turning point right here. This graph has one turning point, and if I add 1 to it, what would I get? 1 plus 1. What is that? 2. That would be the least possible degree of that graph, which we knew already, because what is that the graph of? X squared, okay? Yeah. All right, so let's use all this information on these graphs. Determine whether each graph is the graph of a polynomial function. If yes, state the least possible degree. If no, state why. And this corresponds with these homework numbers. So A, would you say yes or no? Absolutely not, right? This is a no, big fat no. Because why? What would you say? All right, because sharp turn. All right. What would you say about B, yes or no? It is a yes. And we want to know the least possible degree, so we need to find turning points. So how many turning points do you think this has? 2, right? 1 here, where it's going up and then it goes down, so that's the complete opposite direction. And then 1 here, it's going down and now it goes up. What's the least possible degree if it has 2 turning points? 3, right? It's 2 plus 1. So the least possible degree is 3. Let me show you an example of something that looks like it's a turning point, but it's not. If I have a graph that's going like this, this is a turning point. This is not. That's a shimmy, which is not an actual thing. But you see, it's just like shimmying, and it's down, and it's still going down. Never at any time did it turn and go up. Okay, so this is not a turning point. This is, because it went in a completely opposite direction. C, do you think that's a yes or a no? Yes. It absolutely is a yes. How many turning points do you see? 3. Es la verdad. So we have 3 right here. So what's the least minimum degree, or possible degree? 4. 3 plus 1, 4. C, yes or D, sorry, yes or no? No, right? And what would you give for a reason? because it breaks. Breaking my heart. Because it breaks or it jumps or something like that. Okay. All right, so that is first section of material done. Let's look at this next section. I'm not trying to insult your intelligence on this section. You're really just looking at the graph and telling me the end behavior. What's the end behavior on this first one? Down, up, right? And just real quickly, let's review the concept of end behavior. Bless you. The specific concept is as x goes to negative infinity, what is the graph doing? It's going down. And as x approaches positive infinity, what is the graph doing? It's going up. So that's what we're talking about, the end behavior. And that would be important information if you were trying to predict something or you had actual data that your graph was based on and you wanted to know what would happen as those quantities increased or decreased. What about the second graph? Up, down. Last one. Down, down. Just pick those up and so. Okay. That's the entire section. Any questions about that section? No, I don't think so. But here's the thing about this section. It was easy to figure out the end behavior because we had a picture. And in fact, the next section we're going to find end behavior and y-intercept. If I wanted y-intercept in this slide, it'd be really easy as well. I would just look at the graph and figure out where it crosses the y-intercept. But in this next section, here, we don't have pictures, okay? We just have functions. So there's some other kind of information that we're going to use to figure out those same things when we don't have a picture. And so we're going to fill out this table and then talk about y-intercept, right? When we're trying to figure out end behavior and we're not lucky enough to have a picture, we're going to talk about the combination of two different pieces of information. One is the a value and one is the degree, right? Remember, the degree is the highest exponent of a function. So like here, in this problem we're about to get to, what's the degree on that function? 4. And what would the a value be? 0.5, right? It's the leading term, or the leading coefficient. So here's how we'll use those two pieces of information to figure out end behavior without having to graph or draw a picture at all. The first thing we will always want to know is if a is positive or negative. So if you're still iffy on your inequality symbols, this means a is bigger than 0, so that's positive. And this one means a is less than 0, that's negative. And the other piece of information we're interested in is the degree. We're interested if the degree is even or odd. Now remember, this is just figure out end behavior. We're going to use it up, down, up, or what is it? We're going to fill out this chart, and your job before your quiz or test day is to have this chart memorized. I don't ever memorize this chart. I sort of build it every time I need to use it, and here's how I do that. Bless you. So you're welcome to just straight memorize it, or if you can remember what I'm about to show you, you can just build it yourself or just use your common sense from this information. One of our parent functions that was an even degree with a as positive is this one. Okay, this is x squared. That's even degree when a is positive. What's the end behavior on that? Up, up. This will be true for anything with an even degree with a positive leading term. So your positive leading term could be 8x to the 52, and it's going to go up, up. Okay. What happens to this graph when we make the front of it negative? What happens to the graph? It flips. It goes this way. Now, what's the end behavior? Down, down. So when you have an even degree and a negative leading coefficient, it's going to go down, down. And it might be like something crazy, like all kinds of stuff going on in the middle, but it'll still be just down, down. Okay? Whatever. All right. So let's talk about odd degree. Here is a parent function of odd degree with a positive a. This is x cubed. Not very well drawn x cubed, but you get the point. It has a shimmy, right? Not a turning point. What's its end behavior? Down, up. How will that change if the leading term is negative? What would this become? Up, down. And y-intercept, all I really want you to write here is a quick reminder. That means x equals 0. What is y when x is 0? And we'll use that in just a second. Does anybody need the screen up anymore? Good? All right. Let's put all that together with this problem. This problem is asking me to state the end behavior and the y-intercept of these functions. All right? They're in standard form. The end behavior is based on two things. Is A positive or negative? Yes. Which one? I should say, what is A positive? You logically answered, like if you followed your logic rules, you answered correctly. So A is positive. And is the degree even or odd? Okay. So what's the end behavior when A is positive and the degree is even? Up, up. Just like x squared. Even degree, A is positive, it goes up, up. And then the y-intercept. Now this means, what does y equal when x is 0? Okay, because that's where the graph crosses the y-axis. X is 0 everywhere on that line. Now I could put 0 in here for x to the 4th, 0 in here for x cubed, and 0 in here for x, and figure out what all that math is, and step by step by step. But I'm not going to do that. Like, why do I not want to waste my time doing that? What will happen when I put 0 into this term? This becomes 0. What about this term? 0. What about this one? 0. So anywhere you see an x, when you put 0 in, they're just dropping off, leaving you with the constant. Okay, so whatever the constant is your y-intercept. So you're welcome to do the math by plugging in the zeros and just double checking, or you could just believe me that your y-intercept is 0, 6. And please write it as a point in ordered pair. So the end behavior is up, up, and the y-intercept is 0, 6. You try B if you haven't already. So in behavior, our A is negative, it's less than 0. Our degree is odd. For regular odd degree, it's down, up, but this is negative, so we flip that up, down. Okay. And then the y-intercept, when x is 0, what does y equal? Negative 3. Right? So we were able to figure out that information without graphing anything. Right? And the reason why these are important characteristics of a graph is if you had some kind of data, when x equals 0, that's always an interesting thing because that's at the beginning of whatever you're measuring. You want to know like your starting point. And then again, the end values are important because it indicates a trend as it keeps going one direction or the other. Then you can make information based. Oh, I forgot I had this thing. It says my mom still hasn't noticed is what it says under that thing. You see it? Yeah. He doesn't belong there. But he's being very reverent. Okay. He's respecting other religions that are not his own. And he's being reverent. Seasonally appropriate. Okay. So these problems right here. Sorry, I did not mean to sidetrack us on a religion topic. This section right here, we're going to find the degree. We're going to find end behavior. We're going to find y-intercept. Some of that stuff we talked about here. But what's different in this form that we had in these problems and this form? What kind of form is this? factored form, right? It's factored form. The other section, that was really easy. It's really easy to find the a. It's really easy to find the degree because we just have to look at the equation. On this one, we have to do a little bit more Sherlock Holmesing and using clues to figure out the answers that we need. Now, I'm going to start by showing you something. You don't have to write this down. I just want your eyes and ears, your ears and your eyes. No, I did not say that. You said that. See how I purposely did not say that today? I did a good job. X minus 2 times 2x plus 3. This is a factored form, right? If I were to FOIL this out real quickly, 2x squared, that'd be negative 4x plus 3. Negative 2 times 3 is negative 6, right? Now, that was really easy to FOIL and get something. And in this form, it is like that last section. I can see an a value very easily, the degree, and the y-intercept. I can read all that stuff right now. The problem is we don't want to take this problem and multiply everything out. That's going to get really ugly really fast, because how many x plus 2's do I have here? 3. And then over here, I've got 2 of those factors. This one's an x squared, and then I have that last term. It's not hard to multiply that all out, but it's really long and ugly. You probably make lots of mistakes because it just is, and we don't want to do that. So what we're going to do instead is have a few shortcuts. All we really need to figure out is the first term of the polynomial and the last term of the polynomial. We don't care about anything in the middle. And so how did we get, when I FOILed this, how did I get that first term? I multiplied the first terms. How did I get that last term? I multiplied the last terms. And that's exactly what we're going to do here. We have to be just a little bit careful because of the exponents. But that's the basic idea of what we're about to do. Multiply all the first terms, multiply all the last terms. Okay? So keeping that in mind. Keeping that in mind. So I've got 2 factors. Well, I actually have 4 factors, just 2 unique ones, 2 distinct ones. In this first factor, x plus 2 cubed, what's the first term? Okay, it's a 1x, but how many times does that occur? 3, so it's x cubed. And in this factor, I have 1x, and it's not being raised to any power. So when I multiply all that out, I get x to the 4th. And I didn't have an a value, but we understand it's really what? 1, right? Okay, so there's my first terms, and we'll use that information in just a second. So if you were to go through the trouble of doing x plus 2 times x plus 2 times x plus 2 times x plus minus 3, this would be your first term. And if you went through the trouble of doing all that, your last term would be positive 2 cubed times negative 3. Okay, so that's 2 cubed is 8 times negative 3 is negative 24. And there'd be lots of ugly stuff in the middle of your first and last term, but we don't care about that. So now we answer the questions from the problem. State the degree of the function. What's the degree? 4. Absolutely, there's my degree right there, the highest exponent. The degree is 4. And behavior, so I've got to look at 2 things for that. I need to know, is a positive or negative? What is it? Positive, because it's 1. So a is positive. It's greater than 0. And then I need to know, is the degree even or odd? Okay, so it's even, because the degree is 4. So degree is even, a is positive. What's the end behavior? Up, right? Just like x squared is up when a is positive, so would this be x to the 4th. And then the y-intercept, I don't want you to write just negative 24. Please write it as an ordered pair, 0, negative 24. You try, actually, don't try that b just yet, okay? What I want you to do is that, this was the bottom left of your notes. On the right-hand side, the a, I want you to do that. Yes, do that one, and then we'll go back to the b. So my first term in the first factor is just an x. The second factor, it's x cubed. And the third factor is 5x. So when I multiply the coefficients together, it's 1 times 5. And then the x's, I add up all their degrees. It's 1 plus 3 plus 1, 5. Okay. So who got that for their first terms? Okay. We'll use that information in a second. And someone asked me, can they just add up the degrees? Like, this first factor is a 1 there. There's a 3 here. There's a 1 here. Could they just go 1 plus 3 plus 1? The degree is 5? Absolutely, yes. You can. I just am combining some stuff here, just doing the a and the degree all at the same time. It's whatever you like. Whatever shortcut you can figure out for yourself, if it gets you the right answer, by all means do that shortcut. And then for the y-intercept, now we're multiplying the last terms together. So that's 1 here, negative 2 cubed here, and negative 3 here. So that's 1 times negative 2 cubed times negative 3. So negative 2 cubed, negative, 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 what's that sign going to be? Negative. So this is negative 8 times negative 3, which is positive 24. So all we've done right here is gathered information. I haven't actually answered the question. So now we do the actual answer. State the degree of the function. What's the degree? 5. The end behavior is a combination of things. It's a is positive or negative? Positive. And is the degree even or odd? Odd. So what's odd? What's the end behavior on an odd function with positive degree? It's just like x cubed, right? It's down, up. And then the y-intercept is 0, 24. Right. So those are kind of straightforward as far as these problems go. We're going to talk about the other B's have negatives in the front. We're going to talk about how that changes stuff up a little bit. Bye, Sam. See you tomorrow. So back to the left problem, the left section, the bottom, B. So this is different mainly because there's a negative out front. All that really means is if you're going to do everything the same, you're just going to make it negative at the end. Because what's happening is you're doing, like if you were to multiply all this out, like you did x plus 1 times x plus 1, you figured that. You did time, and you had this huge long polynomial, you would just take that negative and distribute it through. Okay? So you're just going to do the regular math and then make it negative at the end. You're like kind of distributing it. So here's what we did before. We still are going to take the first terms and multiply them together with a negative out front. So that negative just comes down. And then I have x squared. Okay, notice I'm not putting that negative inside there. The negative itself is not being squared. It's just tacked on out front, okay? And then that x squared, and then that x. So that's a negative x squared times x times x to the 1, negative x to the 5th. And then we multiply the last terms together. So that's in 1 squared, and don't forget to bring that negative down out front. 1 squared times 3 times a negative 6. So that's negative 18, which is a positive 18. And take a minute and answer the rest of the problem based on that information. Okay. So remember again, this is my first term here. This is my A, my degree. So the degree here is 5. The end behavior is a combination of things. Is A positive or negative? Negative. And is the degree even or odd? Odd, because it's 5. And so if it's odd, normally it goes like this, but now it's negative, so those change. Is that stupid? So it's up, down. Okay. And then the y-intercept is 0, 18. So these problems right here at the very beginning of the lesson when I said any one of these things taken by itself is easy to understand. But when you go to try and put it all together and keep everything straight, then it's like, wait, hold on, just a second. I'm going to put the answer for that last B up just in case you work there so you can see, but I'm not going to go through it as a class. All right, I'm just going to pass out your homework because I feel like I've sort of tortured you enough already.